Hello and welcome to this revision session for Paper 2 in AQA A-Level Physics, and in today's revision session we're going to look at how to answer examination questions on A-Level Physics Paper 2 and in particular multiple choice questions. So if we've been successful and we've learned in today's lesson, we'll be able to answer A-Level Physics examination style questions, assess our understanding of A-Level Physics, and understand what topics we need to improve upon for AQA A-Level Physics. So how should you be carrying out this revision session? Well, when you complete your work in this revision session, divide your piece of paper into two sections. Make the section on the left hand side larger than the right hand side, and in this section write down your working out and answers to the questions in the revision session. When you're doing this, make sure you write in full sentences and show your full working out. Whilst in the right hand side, write down any bits of information which you find useful or any hints and tips on answering questions from this revision session. And at the end of the revision session, write up these notes into a revision sheet for you to use independently. So how should you be revising AQA A-Level Physics? Well, the first step is to learn the key facts. So use revision guides, class workbooks, student prep notes and the textbook to learn the key ideas of the course. The second step is to test yourself. So use things like Caboodle, Seneca, knowledge checkers to quickly test your own knowledge. The third step is then to use exam prep books, homework books, supervised study books, additional workbooks to answer exam questions and mark your own work. So the three steps of learn the key facts, testing yourself and practicing exam style questions are how you should revise AQA A-Level Physics. So let's have a look at some questions now on the paper 2 topics with a multiple choice section of the paper. So let's have a look at gravitational fields. So the first question says the radius of a planet is r. The gravitational potential of the surface of the planet due to its mass is minus 4,000 joules per kilogram. What is the gravitational potential at a distance of 2r from the centre of the planet? So pause the video now, then unpause the video when you want to go through your answer. Right, the answer here is going to be B, because we know that V, the potential, is minus gm over r. So this tells us that if r doubles, well therefore the potential halves. So therefore when it's at 2r, the potential is half, so it's now gone from 4,000 to 2,000, the answer is B. The next question says gravitational field lines and lines of equipotential, and then you've got to finish the sentence. So pause the video now, then unpause the video when you want to go through your answers. Right, the answer here is going to be D, because it's a fact that the lines of equipotential are always perpendicular to the field lines in all gravitational fields. So by that logic, the only answer possible is D. The next question says, in the graphs below, r is the radius of the Earth. Which graph shows the variation of the gravitational potential V with a distance d from the surface of the Earth? So pause the video now, then unpause the video when you want to go through your answers. Right, so in this one, we know that the gravitational potential is always a negative value by definition, so A and B cannot be right, so it has to be either C or D. So there must be a non-zero value of the potential at the surface, because we take the potential as being measured from the centre of the planet, so therefore our answer must be D, so the answer therefore is D. The next question says, satellites X and Y orbit the Earth at distances r and 4r respectively as shown in the diagram. Which statement is incorrect? So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this question? Well, we know that as t squared is directly proportional to r cubed, Kepler's law of orbits, the further away the satellite, the slower its orbital speed, and therefore y will be going slower than x. So from that idea, the only correct answer can be A. The next question says, which of the following gives a correct unit for g squared minus g? So pause the video now, then unpause the video when you want to go through your answer. Right, for this one, we know that big G has units of N to kilograms to the minus 2, M to the minus 2. We know that from the equation sheet. And small g has units of newtons per kilogram. So therefore, we can pop that in and we can say G squared over G is N squared kg to the minus 2 over N kg to the minus 2, M to the minus 2. The kg's cancel through. We then have n squared over n m to the minus 2, so therefore one of the n's cancels through, so it's therefore n m to the minus 2, so our answer is therefore D. The next question says, Ganymede and Io are two moons of Jupiter. The orbital radius of Ganymede is greater than the orbital radius of Io. Which row shows the moon with a greater orbital speed and the moon with a greater angular speed? So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this question? As we mentioned before, t squared is directly proportional for r cubed in Kepler's law of orbits. So the further away the moon is, the slower the orbital speed it will have, because the time it takes to orbit will be slower. So therefore, the slower the orbital angular speed, so our answer is going to be A. Now the next question says, a planet has a radius half the Earth's radius and a mass a quarter of the Earth's mass. What is the approximate gravitational field strength on the surface of the planet? So pause the video now, then unpause the video when you want to go through your answer. Right, so for this question we know that the gravitational field strength is equal to gm over r squared. That's from the equation sheet. So this tells us that if the radius halves, then g will increase by a factor of 4 because it's g to the proportion of 1 over r squared. We know that the mass decreases by a factor of 4, so therefore the two values cancel each other out, so therefore g is going to be unchanged, and we know approximately on Earth that g is 10 newtons per kilogram, so the answer is C. Let's now have a look at some questions on the electrical fields topic. So the first question says, the diagram shows a uniform electrical field strength E of 20 volts per meter, a charge of 8 millicoulombs along a path of JKLM. The distance of J to K is 2 meters, the distance of K to L is 1 meter, and the distance of L to M is 1 meter. What is the net work done moving the charge from J to M? So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this question? Well, we know that for row A, okay, we know that the electrical field strength requires R to be squared. So what we can say is that work done is Q times delta V. So therefore we know that 8 times by 10 to the minus 3, because that's its charge, millicoulombs into coulombs. Then we work out what its change in potential is. So it's from 2 minus 1 times by 20, because then we're going to work it through our change in potential like so. Okay, and then as a result, so therefore it's 0.16 joules, so that works through to be 160 millijoules. So our answer is therefore A. The next question says, two fixed parallel plates X and Y are at constant potentials of plus 100 volts and plus 70 volts respectively. An electron travelling from X to Y experiences a change of potential energy, for which line A to D in the table shows correctly the direction of the electrostatic force F on the electron and the value of the electrical potential energy. So, pause the video now, then unpause the video when you want to go through your answer. Right, so the work done, which is the electrical potential energy, is Q times by delta V. So the charge is the charge of the electron, which is 1.6 times 10 to the minus 19, times by the change in potential, which is 100 to 70, which is 30. So therefore our work done is 4.8 times 10 to the minus 18 joules. Now we know that 1 EV is 1.6 times 10 to the minus 19 joules, so therefore the work done in EV is 1 divided by the other, so it's 30 EV. Now work is being placed out of the system because it's going down the potentials. Now the force acts in the opposite direction of the electron, as the force takes a direction a positive charge would take and the electron is a negative charge, so therefore our answer is A. The next question says the electrical potential at distance r from a positive point charge is 45 volts. The potential increases to 50 volts when the distance from the point charge decreases by 1.5 meters. What is the value of r? So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this question? Well, we know V is directly proportional to 1 over R. You can work that out from the equation given to you on the examination sheet. Now V has increased by 10% because 5 over 50 times by 100 is 10%. So this means the distance must have decreased by 10% because they're in inverse proportionality to each other. So if 10% is 1.5 meters, well therefore we can work out that 100% is therefore going to be 15 meters. So therefore our answer is 15. The answer is D. The next question here shows the diagram with electrical field lines around 3 charges, Q1, Q2 and Q3. Which row gives the signs of the charges Q1, Q2 and Q3? So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this question? Well, electrical field lines move in the direction that a positive charge would take. Now Q1 and Q2 are therefore positive because the field lines are moving away from them and positives will repel other positives. Now Q3 is a negative because the field lines are moving towards it because positives want to go to negatives. So our answer is D. The next question says, the diagram shows 4 point charges, each plus Q, at the corners of a square of side 2A. What is the electrical field strength at P, the centre of the square? So pause the video now, then unpause the video when you want to go through your answer. Right, so the answer here is A, because the electrical charges cancel each other out as they each have the same charge and they're equidistant away from each other. So therefore, the overall electrical field strength, which is a vector, will cancel each other out because they're all acting at the same strength at the same distance from that centre point P. The answer is A. The next question says, a deuterium atom consists of one electron and a nucleus. The nucleus has one proton and one neutron. The electrostatic force on an electron due to the deuterium nucleus is Fe, and the gravitational force on the electron due to the deuterium nucleus is Fg. So what's the ratio, Fe over Fg? So pause the video now, then unpause the video when you want to go through your answer. Right, so to answer this question, you've got to work out the electrical force. Now we look on our equation sheet and we see that it's F is equal to K Q1 Q2 over R squared, and the gravitational force is F equals G M1 M2 over R squared. Pop in the numbers. Now you'll notice as well, because they both have the term R squared in, you don't actually need to know the value of R because they'll just cancel through when you divide one by the other. So therefore you can work it through without considering R squared, so we get our answer out to be 1.1 times 10 to the 39. The answer is C. The next question says, an electron moving with a constant speed enters a uniform electrical field at right angles to the direction of the field. What is true about the force acting on the electron? So pause the video now, then unpause the video when you want to go through your answer. Right, our answer here is B, because the field lines show the direction that a positive charge would take if it's placed there. So as the electrons are negatively charged, the electron will move in the opposite directions to the field line, and if the force is perpendicular to the direction of the motion, well then the force will change the direction but not the speed of the particle, because acting as a centripetal force. So therefore our answer is B. Right, we'll now have a look at some questions concerning capacitance. So, the initial charge stored by a capacitor of capacitance 0.50 microfarads is 2 microcoulombs. The capacitor is then discharged through a resistor. How much energy is stored by the capacitor after a time equal to one time constant? So pause the video now, then unpause the video when you want to go through your answer. Right, for this one the answer is B, because after one time constant the charge by definition will have dropped to 37% of its initial value. So 37% of the initial value is 7.4 times 10 to the minus 7 coulombs. We then know from the equation sheet E equals a half Q squared over C. Capacitance is a fixed term, so therefore we just know it's 2 times 10 to the minus 6 because it's microfarads is given in the question. So working it through like so. So you work it out to be 5.4 times 10 to the minus 7, which is 0.54 times 10 to the minus 6. So it's going to work it through to the answer to be B. The next question says, a capacitor of capacitance C has a charge Q stored on the plates. The potential difference between the plates is doubled. What is the change in the energy stored by the capacitor? So pause the video now, then unpause the video when you want to go through your answer. Right, so how to answer this question? Well, the original stored by the capacitor is equal to a half Q times by V squared. The equation is given to you on the equation sheet. So if the potential difference is doubled, well therefore the energy will quadruple because E is directly proportional to V squared. So the new energy is equal to 4 times by a half QV squared. So therefore it's 2Q V squared. So the energy change is going from 2QV squared minus a half QV squared, which is 3 over 2 QV squared. Now as we know C is Q over V, well therefore the energy change is going to therefore be 3 over 2 Q squared over C. The next question says, the graph shows how the charge on a capacitor varies with the potential difference across the capacitor. What is the additional energy stored by the capacitor when the potential difference increases from 200 volts to 400 volts? So pause the video now, then unpause the video when you want to go through your answer. Right, the answer here is C, because to find the additional energy stored, you've got to find the area between the 200 volts and the 400 volts on the graph, because the area under the line is your energy stored. So you work out the area between 0 and 200 volts, so it's a half times by 2 times by 10 to the minus 3 times by 200, it's just the triangle, so it's 0.2 joules. Then do the area between 0 volts and 400 volts, so it's a half times by 4 times 10 to the minus 3 times by 400, remember 10 to the minus 3 is because it's in millicoulombs on the y-axis, so therefore it's 0.8 joules, so therefore the difference is 0.6 joules. Our answer is C. The next question says, which of the following statements about a parallel plate capacitor is incorrect? So pause the video now, then unpause the video when you want to go through your answer. Right, so the answer is C, because we know that capacitance is charge over volts over potential difference, therefore charge is equal to capacitance times by potential difference. So it indicates to us that charge and potential difference are in direct proportion for a constant capacitance, which is true for a parallel plate capacitor. So our answer is therefore C. The next question says, a capacitor of capacitance 10 microfarads is charged through a resistor R to a potential difference of 20 volts using the circuit shown. When the capacitor is fully charged, which of one of the following statements is incorrect? So pause the video now, then unpause the video when you want to go through your answer. Right, so when a capacitor is fully charged, the potential difference across the capacitor equals the potential difference of the EMF source. That's just a fact. And the PD across the resistor is 0 because there's no current, because it's fully charged. So therefore, if we say E equals a half CV squared from the equation sheet, we can say it's a half times by 20 squared, the capacitance, times by 10 times 10 to the minus 6, sorry, that's the potential difference, sorry, times by 10 times 10 to the minus 6, which is the capacitance. So therefore, our answer is 2 millijoules. Now, however, in the charging process, the energy will be lost to resistance, so therefore it's going to be slightly less than 2 millijoules. So therefore, as a result, the answer is B. The next question says, a parallel plate capacitor is fully charged and then disconnected from the power supply. A dielectric is then inserted between the plates. Which row correctly identifies the charge on the plates and the electrical field strength between the plates? So pause the video now, then unpause the video when you want to go through your answer. Right, so the point is, in this particular question, the dielectric will not affect the charge as the capacitor is fully charged and disconnected from the power supply, so it's unable to be changed. Now the dielectric will decrease the electrical field strength since the polar molecules of the dielectric will align anti-parallel to the capacitor's electrical field. This will produce an electrical field in the opposite direction, reducing the capacitor's overall electrical field strength because it's a vector, so therefore our answer will be D. The next question says, a 500 microfarad capacitor is charged to a potential difference of 10 volts. It's then discharged through a 100 kilo ohm resistor. What is the time taken for the potential difference to fall from 10 volts to 5 volts? So pause the video now, then unpause the video and you'll want to go through your answer. Right, so how do you answer this question? Well, we know that from the work we've done in capacitors that the time to half is log 2 to the times by the time constant, which is log 2 RC. So we can do log 2 times by the resistance, which is 100 times 10 to the 3, because we go from kilo ohms to ohms, times by 500 times 10 to the minus 6, because we go from microfarads to farads. So we pop that through and we get 35 seconds out. The answer is A. Let's now have a look at some questions concerning thermal physics. So, a 60 gram solid metal sample is heated by an electrical heater. The heater operates at a voltage of 230 volts with a current of 1 amp. The temperature of the sample changes as shown below. What is the specific latent heat of vaporization of the metal? So pause the video now, then unpause the video when you want to go through your answer. Right, so we know that the equation is E equals ml, so therefore L is equal to E, or work done over the mass. Now the work done is going to be power times by time, so therefore the power in an electrical circuit is VI, so it's VI times by T over M, so we can pop the values in. We can do 230 times by 1 times by 64 divided by 0.060 grams into kilograms, and we get 245 times 10 to the 3, so it's approximately going to be D. The next question says, a 1 kilo ohm resistor is thermally insulated and a potential difference of 6 volts is applied to it for 2 minutes. The thermal capacity of a resistor is 9 joules per Kelvin. The rise in temperature in Kelvin is what? So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this question? Well, we've got potential difference and we've got resistance. So we can say that power is V squared over R. So we pop in the numbers, we say it's 6 squared over 1000 because kilo ohms into ohms. So it's 0.036 watts. Now because energy is power times by time, if we then multiply it by the time, 2 minutes in seconds, 120, we get our energy to be 4.32 joules. Now we know E equals MC triangle T. So therefore triangle T is E over MC. So it's energy over the mass times by the specific heat capacity, so it's 4.32 over 1 times by 9, so therefore it's 0.48 Kelvin. The answer is C. The next question says, a raindrop of mass m falls to the ground at its terminal speed v. The specific heat capacity of water is C and the acceleration of free fall is g. Given that 25% of the energy is retained in the raindrop when it strikes the ground, what is the rise in temperature of the raindrop? So pause the video now, then unpause the video when you want to go through your answer. Right, so to answer this question, we can say that the kinetic energy, half mv squared, is equal to the thermal energy, mc triangle t, but only by a factor of 25%. So multiply that kinetic energy by 0.25. So say that's the energy that's being transferred across. So we can then rearrange it and say, well, a half mv squared equals 4 mc triangle t. We can then rearrange it to make triangle t the subject, and triangle t equals mv squared over 8mc. The m's cancel through to get v squared over 8c. Our answer is D. The next question says, the temperature of a room increased from 283 Kelvin to 293 Kelvin. The RMS speed of the air molecules in the room increases by a factor of what? So pause the video now, then unpause the video when you want to go through your answer. Right, so we know that from thermal physics, a half mc squared is equal to 3 over 2 kt. Now we know that in this case, the mass and k are constants, so therefore we can say that 3c squared is equal to t, or proportional to t, so therefore c is directly proportional to the square root of t over 3, so therefore it's directly proportional to the square root of 10, which is the change in temperature, from 283 to 293, divided by 3, so we work it through to be 1.04, our answer is B. The next question says, a fixed mass of an ideal gas initially has a volume V and an absolute temperature T. Its initial pressure could be doubled by changing its volume and temperature to what? So pause the video now, then unpause the video when you want to go through your answers. Right, so we know the ideal gas equation is PV equals nRT, so therefore P is equal to nRT over V. Now to double P, you could either half T or quarter V, so therefore our answer is going to be B. Now, a fixed mass of gas occupies a volume V. The temperature of the gas increases so that the root mean square velocity of the gas molecules is doubled. What will the new volume be if the pressure remains constant? So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this question? Well, we know that V over T is a constant, that's a fact. So volume increases at the same proportion that temperature increases if it's going to be a constant value. Now we also know that temperature is directly proportional to speed squared, c squared. So therefore, if c is doubled, well then for T would have to be quadrupled. So if T is quadrupled and it stays in the same proportion as V, well therefore V quadruples, so our answer is D. The next question says, which one of the graphs below shows the relationship between the internal energy of an ideal gas and the absolute temperature of the gas? So pause the video now, then unpause the video when you want to go through your answer. Right, so here we know that the temperature and the internal energy must be in direct proportion to each other. Now because absolute temperature is used, so it's kelvins that's being used, it therefore must cross the x-axis at 0, because we know that with the absolute temperature scale, when there's no energy, there's no temperature, so it must go through 0, 0. So the only answer possible is A. Then let's have a look at some questions concerning magnetic fields. So this question says, three identical magnets P, Q and R are released simultaneously from rest and fall to the ground from the same height. P falls directly to the ground, Q falls through the centre of a thick conducting ring, and R falls through a ring which is identical except for the gap cut into it. Which of the statements below correctly describes the sequence in which the magnets reach the ground? So pause the video now, then unpause the video when you want to go through your answers. Right. So what we should know is the answer is A, because P and R will arrive together because they'll both fall freely under gravity. Now Q will arrive later as the magnet passes through a conductor, which will cause a change in the magnetic flux linkage, which causes an EMF to be induced in the conductor and produces a current. This will produce a magnetic field in the conductor, which acts in the opposite direction to the motion of the magnet due to Lenz's law, and therefore repels it. Now this doesn't occur in R because R is not a complete circuit. So whilst an EMF is produced, there's no current which leads to repulsive magnetic field. So our answer is A. The next question says, the graph shows how the flux linkage through a coil changes when the coil is moved into a magnetic field. The EMF induced in the coil is what? So pause the video now, then unpause the video when you want to go through your answer. The answer here is B, because when there's a change in magnetic flux linkage, an EMF is induced. When there's no change in magnetic flux linkage, there's no EMF induced. So after t equals 0, it's a flat line, so there's no change, so EMF is 0. Before t0, there's a constant change because there's got a constant gradient, so therefore a constant EMF is induced. The answer is B. The next question says, using the circuit shown and with the switch closed, a small current was passed through the coil X. The current was slowly increased using a variable resistor. The current reached a maximum value and was then switched off. The maximum reading on the microammeter occurred when what? So pause the video now, then unpause the video when you want to go through your answer. Right, the answer is C, because the current is induced in a circuit when an EMF is induced. Now, an EMF induced is directly proportional to the change in magnetic flux linkage. So the bigger the change in flux linkage, the greater the reading. Now, the biggest change, either positive or negative, is when the current is switched off, because all of the flux linkage is removed. This gives you the biggest change, so our answer is C. The next question says, a student is using an oscilloscope to investigate an AC voltage waveform when the input voltage is sensitive on the scale to be 1 volt per division and the time base setting is 10 milliseconds per division. The trace appears as follows. The student then changes the input sensitivity to 2 volts per division and the time base setting to 20 milliseconds per division. What will be observed whilst applying the same signal to the input terminals? So pause the video now, then unpause the video when you want to go through your answer. Right, so the answer here is D. So because the time base is being made larger, you'll have more waveforms being fitted onto the screen. And whilst the Y gain is being made larger, that tells us our waves are going to appear smaller than they have before, because each division is worth more. So therefore our answer is going to be D. The next question says a transformer has 1200 turns on the primary coil and 400 turns on the secondary coil. A primary coil draws a current of 0.25 amps from a 240 volt AC supply. If the efficiency of a transformer is 83 volts, what is the current in the secondary coil? So pause the video now, then unpause the video when you want to go through your answer. Right, our answer here is going to be C, because we know from the equation sheet that MP over VP equals NS over VS. That's the transformer turns equation. We can pop in all the values, and then before we see VS is equal to 240 times by 500 over 1200 to equal 100. Now the power in the secondary equals the power in the primary times by a factor of 0.83 because it's 83% efficient. So therefore we can pop in our values and we can say I equals 0.25 times by 240 times by 0.83 over 100, which is 0.50 amps. Our answer is C. The next question says, which one of the following statements concerning power losses in a transformer is incorrect? Power losses can be reduced by what? So pause the video now, then unpause the video when you want to go through your answer. Right, so power losses can be reduced by either laminating the core to reduce eddy currents, by using thicker wires as it lowers the resistance because the cross-sectional area of the wire has increased, or by using a soft magnet to reduce hysteresis. So the one that doesn't reduce power losses is the high resistance widens. The answer is B. The next question says, a coil with 20 circular turns, each a diameter 60 mm, is placed in a uniform magnetic field of flux density 90 milliteslas. Initially, the plane of the coil is perpendicular to the magnetic field lines as shown. The coil is then rotated about the vertical axis by 90 degrees in a time of 0.20 seconds so that its plane becomes parallel to the field lines as shown in figure Y. Assume the rate of change of flux linkage remains constant. What is the EMF induced in the coil? So pause the video now, then unpause the video when you want to go through your answer. Right, so we know induced EMF is equal to the change in flux linkage divided by the change in time. Now when the angle is 0 degrees, the flux linkage is 0. Now when the angle is at 90 degrees, it's 90 times 10 to the minus 3, because it's BAN, times by the area, which is pi r squared, so it's pi times by 30 times 10 to the minus 3 squared. Remember the diameter is 60 millimeters, so the radius is 30 millimeters. Then you times it by 20, which is the number of turns. Then you divide that all by the time, 0.20. Our answer is 25 times 10 to the minus 3 volts. Our answer is C. Let's now have a look at some questions concerning nuclear physics. So after 64 days, the activity of a radioactive nuclide has fallen to 1/16 of its original value. So the half-life of the radioactive nucleus is what? So pause the video now, then unpause the video when you want to go through your answer. Right, so if in 64 days the activity has gone to 1/16, well therefore working backwards there's been 4 half-lives because we've gone from 1 to a half to 1/4 to 1/8 to 1/16, so therefore we've had 4 half-lives. So if there's been 64 days and there's been 4 half-lives, there's 1 half-life every 16 days. Our answer is D. The next question says, the sodium isotope is a radioactive isotope that can be produced by bombarding the aluminium isotope with neutrons. Which line in the table correctly represents the production of sodium from the aluminium isotope and its subsequent decay? So pause the video now, then unpause the video when you want to go through your answer. Right, the answer here is B, because the sodium isotope is produced with the release of an alpha particle. And since the sodium isotope, you can tell, because it's 2411, is neutron rich, well therefore, if neutron rich isotopes decay via the beta minus decay, so our answer is B. The next question says, in the Rutherford alpha particle scattering experiment, alpha particles have the same energy with fired at the gold nucleus. Now the diagrams below are intended to represent encounters between the two alpha particles and the gold nucleus N, and the alpha particles arriving at different times. Which one represents the best possible encounters? So pause the video now, then unpause the video when you want to go through your answer. Right. Now, the important thing to note is the alpha particles repel from the nucleus because they're both positively charged, and the closer the alpha particle is to the nucleus, the greater the repulsion will be, because it's the electrical force which links into the distance they are from each other. So therefore our answer will be A. The next question says, the diagram here shows the path of an alpha particle deflected by the nucleus of an atom. Point P on the path is the point of closest approach of the alpha particle to the nucleus. Which of the following statements about the alpha particle on this path is correct? So pause the video now, then unpause the video when you want to go through your answer. Right, so at the closest point between the alpha particle and the nucleus, all the kinetic energy of the alpha particle has turned into the electrical potential energy, and so therefore the alpha particle will reduce its movement to a minimum value. So the answer is therefore D. The next question says, the actinium series of radioactive decay starts with the isotope of uranium of mass number 235 and atomic number 92. Which line in the table shows the nucleon and proton number of the isotope after the emission of 5 alpha particles and 2 beta minus particles? So pause the video now, then unpause the video when you want to go through your answer. Right, so in alpha particles in alpha decay you lose 2 protons and 2 neutrons. So therefore in 5 alpha particle events you'll lose 10 protons and you'll lose 20 nucleons, 20 protons and neutrons. Now in the beta minus decay you're going to gain a proton and you're going to lose a neutron. So therefore in the 2 beta decays you're going to gain 2 protons but gain 0 nucleons because you've turned your protons into neutrons. So overall you've gained 8 protons, okay, and then you've lost 20 nucleons, so therefore our answer can only be C. Now the next question says an alpha particle moves with 1/10 the velocity of a beta particle. They both move the same uniform magnetic field at right angles to their motion. What is the magnitude of the ratio of the force on the alpha particle compared to the force on the beta particle? So pause the video now, then unpause the video when you want to go through your answer. Right, so because they're both charged and moving through a magnetic field, we know that F equals BQV. Now B is constant for each particle, so we can just ignore that in our ratios. Now the alpha particle has double the charge of the beta particle because it's got 2 protons to 1 electron, yet has 1/10 of the velocity compared to beta from the question. So therefore we've got a ratio of 1/5, so therefore the answer is B. Now, a radioactive nucleus emits a beta minus particle, then an alpha particle, then finally another beta minus particle. So the final nuclide is what? So pause the video now, then unpause the video when you want to go through your answer. Right, our answer here is A, because a beta particle turns a neutron into a proton, and this happens twice, so the proton number must increase by 2. Now alpha emission releases a helium nucleus, so it reduces the proton number by 2, so therefore the proton number must be staying the same, but the neutron number has changed, so therefore it's the original element, but it's an isotope because it's changed the number of neutrons. The next question says, which of the following best describes the decay constant for a radioactive isotope? So pause the video now, then unpause the video when you want to go through your answer. Right, our answer here is D, because you know that the decay constant is log 2 over the half-life. That's an equation given to you on the equation sheet. So this therefore means that the constant proportionality linking the rate of decay and the number of nuclei, K, must be the decay constant. So therefore our answer has to be D. So that brings an end to our revision session for today. So if we've been successful and we've learned in today's revision session, we should be able to answer A-level physics examination style questions, assess our understanding on A-level physics, and finally understand what topics we need to improve upon for AQA A-level physics. So thank you very much for watching this revision session on paper 2 of AQA A-level physics. Thank you very much and have a lovely day. Hello and welcome to this revision session for AQA A-level physics paper 2. So in today's revision session, what we're going to be doing is we're going to be looking at answering examination questions on A-level physics paper 2, focusing on multiple choice questions. So if we've been successful and we've learned in this revision session, we should be able to answer A-level physics examination style questions. You should be able to assess your understanding on A-level physics and finally understand what topics you need to improve upon for A-level physics. So how should you prepare for this revision session? So when completing your work in this revision session, divide your piece of paper into two sections. Make the section on the left hand side larger than the right hand side, and in this left hand side section write down your working out and answers to the question in the revision session. When you're doing this, make sure you write in full sentences and show your full working out. Whilst in the right hand side, in this section, write down any piece of information which you find useful or any hints and tips on answering questions from this revision session, and at the end of the revision session write up these notes into a revision sheet for you to use independently. So how should you revise A-level physics? So firstly, learn the key facts. Use the revision guide, the class workbooks, the student prep notes and the textbook to learn the key ideas of the course, and you might want to make a mind map or write out notes yourself to do this. The second step is to use things such as Caboodle, Seneca, knowledge checkers to quickly test your own knowledge, and you may wish to do this from your own cue cards. And then finally, step 3 is to practice examination style questions. So use exam prep books, homework books, supervised study books, additional workbooks to answer exam questions and then mark your own work. So you may wish to download your own exam past papers to do this. So your 3 steps of learning the key facts, then testing yourself and then practicing exam questions are how you should revise AQA A-level physics. So let's start off by having a look at a few multiple choice questions on gravitational fields. So the first question says, the gravitational field strengths at the surface of the Earth and the Moon are 9.8 newtons per kilogram and 1.7 newtons per kilogram respectively. If the mass of the Earth is 81 times the mass of the Moon, what is the ratio of the radius of the Earth to the radius of the Moon? So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this particular question? Well, our answer here is in fact A. Now we know that the gravitational field strength is equal to big G m over r squared. That equation is given to you in your examination booklet. Now we can ratio the two field strengths. So we can say that the gravitational field strength of the Moon is equal to the gravitational field strength of the Earth. Now what you will then do is you'll do 81 times the mass of the Moon for the mass of the Earth. We've substituted ME to be 81 mm, as you can see there. Then so therefore you can work all the values through and you can see you're going to get 9.8 over 1.7 is going to give you a ratio of 6. So we can therefore say that when we ratio those values there, you can say that 6 radius of the Earth squared is equal to 81 the radius of the Moon squared. So therefore you can work it through and you get that the radius of the Earth is going to be 3.67 times the radius of the Moon. The next question says, what is the unit for G, the gravitational constant? So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this particular question? Well, our answer here is D, because we know that the gravitational force is big G m1 m2 over r squared. So we've got our equation now which has big G in it. We can then rearrange this and make big G the subject. Then what we can do is we can substitute the units in there. So we can substitute the units in for force, for the radius squared and for the two masses there. So you can see straight away you've got newtons per meter, newtons meter squared per kilogram squared. Then what you can do is you can say that, well, the newton isn't going to be a base unit, and you can see there's no newtons given there, so you can say a newton is kilogram meters per second squared, because you know that F equals ma, and therefore you can substitute that in and simplify it through, and then you can see that in some of the the answers, it gives you joules as a possible answer. So therefore we can work out what a joule is, and we can say that, well, a joule, which is the work done, is going to be force times by distance, which is going to be mass times acceleration times by distance, which gives us a unit of a joule to be kilogram meter squared seconds to the -1. So when we substitute that in, we get joules meters per kilogram squared. The next question says, the separation between the Earth and the Sun varies. The minimum separation is 1.7% smaller than the average separation. The maximum separation is 1.7% greater than the average separation. So what is the ratios of the two forces of attraction, of the force of attraction between the Earth and the Sun at minimum and then maximum separation? So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this particular question? Well, the answer is D. Now, you need to use Newton's law of gravitation to determine the force of attraction, because it's the gravitational force. So we can say F equals big G m1 m2 over r squared. Now, the difference between the two of them is going to be the value you put next to r squared. So as a result, what we can therefore say is we can say that, well, at the maximum separation, we can say that r is going to be 1.017, and at the minimum, r is going to be linked to 0.983. So what we can therefore do is put 0.983 next to r squared at the minimum, and then 1.017 at the max next to r squared in the maximum. We can then ratio the two, work it through, and we get 1.070. The next question says, two planets X and Y are in concentric circular orbits about a star S. The radius of the orbit of X is r, and the radius of the orbit of Y is 2r. The gravitational force between X and Y is F when the angle SXY is 90 degrees as shown in the diagram. What is the gravitational force between X and Y when they are nearest each other? So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this particular question? Well, the answer here is B, because we know that when the objects are closest to each other, the distance between the two, if you look at your triangle, is going to be the square root of 4r squared minus r squared there. So therefore, we can say it's the square root of 3r squared, because we're doing the square root of 4r squared minus r squared, so it's the square root of 3r squared. So therefore, we can take out that r squared and square root it, and so we get r. So therefore, it's equal to r times by the square root of 3. We know that the gravitational force is equal to G m1 m2 over r squared. Now we know that r is equal to r square root 3, so therefore r squared is going to be equal to 3r squared, because we know that square root 3 squared is just 3 and r squared is r squared. So therefore we can say that it's going to be equal to 3f, because we've increased our value of r by 3. The next question says, the gravitational field strength at the surface of a uniform solid sphere is G. The radius of the sphere is big R. What is the density of the sphere? So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this particular question? Well, our answer is B, because we know that the gravitational field strength from our equation booklet is equal to minus Gm over r squared. We also know that m, the mass, is equal to density times by volume. We use this because it asks us to work out density, so we've got to link it into density somehow. Now we know the volume of a sphere is 4 over 3 pi r cubed. That's just a bit of linking into GCSE mathematics. So therefore we can pop that all together and say that G is going to be, well, small g is equal to minus big G, density, which is rho, times by 4 over 3 pi r cubed, all divided by r squared. So r cubed and r squared will cancel through, and then we know that there's we've got a 4 over 3 in there as well. So when we work it all through and make density the subject, we'll get it to be 3 small g over 4 pi big G r, which is the answer B. The next question says, the gravitational field strength on the surface of a planet orbiting a star is 8 newtons per kilogram. If the planet and star have a similar density but the diameter of the star is 100 times greater than the planet, what will the gravitational field strength at the surface of the star be? So pause the video now, then unpause the video when you want to go through your answer. Right, so how to answer this question? Well, our answer is C, because as the density is constant and the diameter has gone up by a factor of 100, then the mass must be increased by 100 cubed, because we know that we need our volume to be going up in the same factor as our mass. So when our diameter has gone up by a factor of 100, and you link into your volume with the diameter as diameter, well, it's radius, but diameter cubed, so therefore our mass must increase by 100 cubed to keep that same ratio, to keep the density constant. So therefore our mass has gone up by 1,000,000, or 1 times 10 to the 6. So what we can therefore say is, when we say gravitational field strength is equal to minus gm over r squared, well, now next to a big M, our mass, we can add in 1,000,000, because it's increased by 1,000,000, and for our value of r, put 100 next to it, because the radius and the diameter have gone up by 100 times. So therefore we can do 1,000,000 over 10,000, because we've done 100 squared there, because it's r is squared in the equation, so therefore it's 100 times larger. Now we know that originally it was 8 for its gravitational field strength, so 8 times 100 is 800. Our answer is C. The next question says, a diagram shows two positions x and y on the Earth's surface. Which line, A to D, gives the correct comparisons at x and y for the gravitational potential and angular velocity? So pause the video now and unpause the video when you want to go through your answer. Right, so how to answer this particular question? Well, unfortunately, the diagram's not been included on the sheet, but the diagram should indicate to us that X is in fact closer to the centre of mass of the Earth than in fact Y is. So as we know that potential is equal to minus gm over r, that equation is given to us in our equation book, that X is closer to the centre of mass of the Earth, so therefore we'll have a greater gravitational potential because the value of r is smaller, so V will be greater. Now, because both objects are on the surface of the Earth and they'll both spin at the same rate because the Earth is spinning at a constant rate on its surface, so therefore our answer is B. The next question says, many satellites in a geosynchronous orbit are also geostationary. Which is a correct statement about geostationary orbits? So pause the video now, then unpause the video when you want to go through your answer. Right, this question is linked all to facts about geostationary orbits. So the answer here is D, because in a geostationary orbit, the satellite remains over the same position on the Earth. That's a fact because it's spinning at the same rate as the Earth is rotating. And so it's orbiting at the same rate that the Earth is spinning or rotating, and therefore it must be in the plane of the equator and move with the Earth's rotation, because it has an orbit of 24 hours, and that's only the case at the equator. And it must go with the Earth's rotation for it to be in the same place above the Earth at all times. So our answer is D. Let's now have a look at a few questions on electrical fields. So our first question says, which of the following is not a similarity between gravitational fields and electrical fields? So pause the video now, then unpause the video when you want to go through your answer. Right, in this one again it's just a fact. The answer here is D, because both fields act on a distance, so we'll follow the inverse square law. Now both fields have point charges and point masses for radial fields. That's just an assumption that we make in physics. And electrical fields act only on charged particles, while gravitational fields act on all massive particles. So therefore the answer, which is not a similarity, is D. The next question says, in a uniform electric field, which statement is correct? So pause the video now, then unpause the video when you want to go through your answer. Right, again, in this one, it's all about facts that you should learn about electrical fields. So the answer is D, because particles experience different forces due to the electrical field depending on the position in the electrical field. In addition, particles will experience different velocities dependent on position, and it'll also be affected by the fact of their mass as well, will affect how their velocity and their acceleration. And then finally, electrical fields can be directed to either the positive or the negative. So therefore our answer is going to be D, because we know that in a uniform field that the field lines must be in equal distance apart, because we've got a uniform field strength, and field strength is given by a measure of how far apart the field lines are. So our answer is D. The next question says, electrical fields and gravitational fields can be represented in similar ways. Which of the following diagrams cannot be used for a gravitational field? So pause the video now, then unpause the video when you want to go through your answer. Right, again, the answer here is linked to all of our facts about fields, and the answer is A, because gravitational fields can only be attractive and cannot be repulsive. Now fields B, C and D are attractive. You can say that because the arrow is pointed in towards the object, and the arrow tells you the direction that a point charge or a point mass would move in that particular field, so it shows you the direction of the force. Now A is a repulsive force because the arrows are pointed away from the object. That can't be a gravitational field. The next question, an ion carrying a charge of plus 4.8 times 10 to the minus 19 coulombs travels horizontally at a speed of 8 times 10 to the 5 meters per second. It enters a uniform vertical electrical field of strength 4,200 volts per meter, which is directed downwards and acts over a horizontal distance of 0.16 meters. Which of the following statements is not correct? So pause the video now, then unpause the video when you want to go through your answer. Right, here our answer is C, because we know that time is equal to distance over speed from our general equation. Speed equals distance over time, so we pop our values in and we get a time to be 2 times 10 to the minus 7 seconds. Now the force follows the field line direction in this case, because we've got a positively charged ion and the field lines point in the direction a positively charged ion would move in that particular field, so it will act vertically down. And also we know that the horizontal component is unaffected by the electrical field, because the electrical field is acting vertically, so therefore it's acting perpendicular to the horizontal and therefore will not influence the horizontal components of the object's motion. The next question says, the diagram shows 4-point charges, each of plus Q, at corners of a square of side 2A. What is the electrical field strength at P at the centre of the square? So pause the video now, then unpause the video when you want to go through your answer. Right, for this one, you've got to consider about distance from P. Now the answer is the electrical field strength will be 0, it'll be A, because the electrical charges will cancel each other out because they've all got the same charge and they're all equidistant from each other. So therefore all these positive charges will therefore cancel each other out because they're on opposite sides of P, so therefore our overall electrical field strength is 0. The next question says, a small sphere of mass m and carrying a charge q is suspended from a thread and placed in a uniform horizontal electrical field of strength E. When the sphere comes to rest, the thread makes an angle of theta with the vertical and the tension in it is T as shown in the diagram. W is the weight of the sphere and F is the electrical force acting on it. Under these conditions, which of the following equations is incorrect? So pause the video now, then unpause the video when you want to go through your answer. Right, so the answer here is going to be D. And why is that? Well, we know that the vertical component is going to be T cos theta is equal to mg, because when we've resolved our angle for tension, which is at, you can see is at an angle there of theta, we can say that the vertical component of tension is T cos theta and therefore must equal the vertical force, which is the weight of the object, and therefore we know that the horizontal component is that T sin theta, which is equal to the electrical force in this instance. Now we can then divide the two components, say T sin theta over T cos theta is equal to the electrical force over mg. That gives us tan theta, because the t's cancel through, and sin over cos is equal to tan, is equal to the electrical force over mg. The electrical force is equal to EQ, so therefore when we rearrange it all, mg is equal to EQ tan theta. The next question says, this diagram shows electrical field lines around three charges, Q1, Q2 and Q3. Which row gives the charges of Q1, Q2 and Q3? So pause the video now, then unpause the video when you want to go through your answer. Right, the answer here is D, because electrical field lines move in the direction that a positive charge would take. Now Q1 and Q2 are positive as the field lines are moving away from them. So therefore positives repel positives, so the direction of arrows for a positive charge is away from the object. Now Q3 is a negative because the field lines are moving towards it, so therefore a positive charge will be attracted to it, indicating it must be a negative. The next question says, a positive ion has a charge to mass ratio of 2.4 times 10 to the 7 coulombs per kilogram. It is held stationary in a vertical electrical field. Which line, A to D, in the table shows correctly both the strength and the direction of the electrical field? So pause the video now, then unpause the video when you want to go through your answer. Right, our answer here is A, because if an ion is balanced and is held stationary, well, therefore the forces acting upon it must equal each other and there's no resultant force. So we can say that weight is equal to electrical force. Now we know that E is equal to F over Q, so therefore we can say that in this case F is going to be equal to EQ. Now we can work this all through and we can eventually say that the electrical field strength must be equal to mg over Q, and therefore we can say it's M over Q, the mass to charge ratio there, times by G. So we can work that through and work it through to say that it's 1 over 2.4 times 10 to the 7, because we want the mass to charge ratio, and we're given the charge to mass ratio in the question, multiplied by G, the gravitational field strength, 9.81 on Earth, and we get 4.09 times 10 to the minus 7. Now again, this force must be acting upwards if the positive ion has its electrical force balanced by the weight, because therefore if the two forces are balanced and weight always acts downwards, therefore the electrical field must be acting upwards. Let's have a look at a few questions now on capacitance. So the first question says, a capacitor of capacitance C is charged to a potential difference V by a power supply. The energy stored in the charged capacitor is W. What would the energy stored be if the potential difference were 2V? So pause the video now, then unpause the video when you want to go through your answer. Right, the answer here is D, because from our equation book, the work done on a capacitor, and the energy stored, the work done in a capacitor is equal to a half times by capacitance times by the potential difference or voltage squared. So therefore, if the potential difference was doubled, it becomes 2V, and it's V squared in the equation, well, the work done must quadruple. So our answer is D. The next question says, the graph shows how the charge in a capacitor varies with time as it is charged through a resistor. What is the time constant for the circuit? So pause the video now, then unpause the video when you want to go through your answer. Right, so the answer here is C. It is 5 seconds, because the time constant is the time it takes to fall to 37% of its initial value. Now you take the initial value as 0.10 microcoulombs, so therefore the value you're looking for is 37% of that, which is 0.037 microcoulombs. Now, when we work this then through, you read off the graph to find where that is, and that is approximately at 5 seconds, so there is our answer. The next question says, the voltage across a capacitor falls from 10 volts to 5 volts in 48 milliseconds as it discharges through the resistor. What is the time constant of the circuit? So pause the video now, then unpause the video when you want to go through your answer. Right, so our answer here is going to be C, because we know that from the discharging equation for a capacitor, we know that V equals V0 e to the power minus t over RC. That equation is given to us in our equation book. We therefore need to find out what RC, the time constant, is going to be. So we can therefore firstly get rid of our exponential by taking natural logs of the left hand side, and on the right hand side it gets rid of the exponential, the e term, and takes that power to be a normal factor in our equation. So we can say natural log v over v0, because we've just taken that v0 across the other side before we took the log. So we went v over v0 equals e to the power minus t over rc. So we can say natural log v over v0 equals minus t over rc. Rearrange it to make rc the subject. Pop our values in from the question. Remember, it's 48 milliseconds, so it's 48 times 10 to the minus 3. And we get 69 times 10 to the minus 3, which is 69 milliseconds, which is C. The next question says, a variable capacitor has a capacitance which can be varied from 6 times 10 to the minus 12 farads to 3 times 10 to the minus 12 farads. The capacitor is set to its maximum capacitance and fully charged using a 48 volt supply. The capacitor is then disconnected from the supply and isolated. Finally, the capacitance is reduced to its minimum value without any charge being lost to the capacitor. Which line in the table correctly shows the potential difference across the the capacitor and the charge is stored after the capacitance has been reduced. So pause the video now, then unpause the video when you want to go through your answer. Well, here our answer is going to be C, because you know that capacitance is going to be equal to charge over potential difference. So therefore for a maximum we can say that charge is equal to capacitance times by potential difference. And we know our maximum capacitance is 6 times 10 to the minus 12, and we know that our potential difference is 48 volts from the question, so we get 2.9 times 10 to the minus 10 coulombs. And then the charge is the same regardless of the capacitance of the capacitor, so therefore we can say V is equal to Q over C, and we've got our C from our previous one. Now we know that when it's been reduced there, we know that our capacitance is going to be 3 times 10 to the minus 12 farads, and therefore we know what our charge is going to be, 2.9 times 10 to the minus 10 from our previous part of the question, so we get 96 volts. The next question says, a capacitor of capacitance 10 microfarads is charged through a resistor R to a potential difference of 20 volts using the circuit below. When the capacitor is fully charged, which of the following statements is incorrect? So pause the video now, then unpause the video when you want to go through your answer. Right, our answer here is going to be B, because when a capacitor is fully charged, the potential difference across the capacitor equals the EMF source, and the potential difference across the resistor is going to be 0, because there's no current going through the circuit, because the capacitor is fully charged, it's holding up all the charge. So therefore we know that if the energy is a half times by capacitance times by the voltage squared, we pop our values through, and we know that we've got a capacitance of 10 times 10 to the minus 6 because it's microfarads, and we know that the potential difference V is 20, so therefore it's 20 squared. We get our answer to be 2 millijoules. However, in the charging process, the energy will be lost to the internal resistance, so as you can see that therefore we won't have 2 millijoules stored in the capacitor, but the energy taken from the battery through the process is going to be 2 millijoules. So our answer is B. The next question says, a capacitor of capacitance C discharges through a resistor of resistance R. Which of the following statements is not true? So pause the video now, then unpause the video when you want to go through your answer. Right, our answer here is going to be A, because you know that the time constant is equal to RC. So if R is increased, the time constant will increase. Now when the resistance decreases, the time constant decreases, the initial current will be higher, and again if PD is the same, well then the initial discharge current is unaffected, so therefore our answer is going to be A. The next question says, a parallel plate capacitor is fully charged then disconnected from the power supply. A dielectric is then inserted between the plates. Which row correctly identifies the charge on the plate and the electrical field strength between the plates? So pause the video now, then unpause the video when you want to go through your answer. Right, our answer here is going to be D, because the dielectric will not affect the charge as the capacitor is fully charged and then disconnected from the power supply, so therefore it's unable to be changed. Now the dielectric will decrease the electrical field strength since the polar molecules of the dielectric will align anti-parallel to the capacitor's own electrical field, so it produces an electrical field in the opposite direction to the capacitor, reducing the capacitor's electrical field strength because it's a vector. So the answer is D. The next question says, a 400 microfarad capacitor is charged so that the voltage across its plates rises at a constant rate from 0 volts to 4 volts in 20 seconds. What current is being used to charge the capacitor? So pause the video now, then unpause the video when you want to go through your answer. Right, our answer here is going to be D, because we know that capacitance by definition is charge over voltage or potential difference. So therefore charge is equal to C times by V. So we've got our value for V to be 4, and we've got our value for capacitance to be 400 times 10 to the minus 6. Therefore our charge is 1.6 times 10 to the minus 3. And we know that current is equal to charge over time. So we take our charge as calculated, divided by 20 seconds, and we get 8 times 10 to the minus 5, which is 80 times 10 to the minus 6, which is our answer D. Let's now have a look at a few questions on magnetic fields. So charged particles, each of mass m and charge q, travel at a constant speed in a circle of radius r in a uniform magnetic field of flux density B. Which expression gives the frequency of rotation of a particle in the beam? So pause the video now, then unpause the video when you want to go through your answer. Right, so our answer here is going to be A, because you know that time is distance over speed, just rearranging speed as distance over time. So our distance is going to be 2 pi times by r, because we are moving in a circular beam, because it says we're going in a circle, so therefore our distance we're going to travel is going to be the circumference, which is 2 pi r. Then we divide it by our speed v. Now we know, because it's a charged particle moving in a magnetic field, that we can say the centripetal force is equal to the magnetic force. When we rearrange that all through, we can say r is equal to mv over bq. Now we know therefore that time is therefore going to be 2 pi m over bq, because we've just linked it in there because we know what r is going to be. So therefore frequency is 1 over time, so we can then flip it over and say it's bq over 2 pi m, so we can therefore get our answer to be A. The next question says, the path followed by an electron of momentum p carrying charge minus e, which enters a magnetic field at right angles, is a circular arc of radius r. What would be the radius of the circular arc followed by an alpha particle of momentum 2p carrying a charge of plus 2e when entering the field at right angles? So pause the video now, then unpause the video when you want to go through your answer. Right, our answer here is going to be B. Once again, if we've got a circular motion undergone due to the magnetic field, we can equate the magnetic force to be the centripetal force, so mv squared over r is equal to bqv. So therefore we can then rearrange it and say r is equal to mv over bq. Now mv is the momentum, p, so therefore r is p over bq. So if we've doubled p, so it's now 2p, and we've doubled charge, so it's 2q, well those values of 2 cancel through to each other, so therefore r is the same value as it was before, so our answer is B. The next question says, a coil with 20 circular turns, each a diameter 60 millimeters, is placed in a uniform magnetic field of flux density 90 milliteslas. Initially, the plane of the coil is perpendicular to the magnetic field lines as shown in figure X. The coil is rotated about a vertical axis by 90 degrees in a time of 0.2 seconds so that its plane becomes parallel to the field lines as shown in figure Y. Assume the rate of change of flux linkage remains constant. What is the EMF induced in the coil? So pause the video now, then unpause the video when you want to go through your answer. Right, so our answer here is going to be C, because you know induced EMF is the change in flux linkage over the time. Now our change in flux linkage is BAN, so we know when the angle is 0, the flux linkage is 0, so therefore we can work out what our flux linkage is at 90 degrees by doing B, which is the magnetic field strength, which is 90 times 10 to the minus 3, because 90 milliteslas, milli means times 10 to the minus 3. We then multiply it by pi r squared, because it's a circle, so it's going to have a circular cross-sectional area, so we know what the radius is. It's going to be 60 millimeters halved, so therefore it's going to be 30 times 10 to the minus 3 squared, times by our value of number of turns, which is 20 as given in the question, and then we can divide that by our time to get our induced EMF, and we get that to be 25 times 10 to the minus 3 volts. The next question says, the diagram shows a coil placed in a uniform magnetic field. In the position shown, the angle between the normal to the plane of the coil and the magnetic field is pi over 3 radians. Which line in the table shows the angles through which the coil should be rotated in the direction of rotation so that the flux linkage becomes a maximum and then a minimum? So pause the video now, then unpause the video when you want to go through your answer. Right, in this question the answer is D, because the maximum flux linkage, which is when you get your conductor cutting through as many field lines as possible, occurs when the coil is perpendicular to the field. So this happens if the coil from the diagram is turned pi over 3 radians clockwise, whilst the minimum flux linkage will occur when the coil is parallel to the field, because you have less field lines cutting through your conductor, which happens if the coil is turned pi over 6 clockwise from that particular position shown on the screen. The next question says, a horizontal straight wire of length 0.30 meters carries a current of 2 amps perpendicular to the horizontal uniform magnetic field of flux density 5 times 10 to the minus 2 teslas. The wire floats in equilibrium in the field. What is the mass of the wire? So pause the video now, then unpause the video when you want to go through your answer. Right, so in this one we know that the answer is B. Why is that? Because if the object is floating in equilibrium, well then our weight acting downwards is equal to our magnetic force pushing upwards. So therefore we can say mg is equal to BIL. We use BIL because it's a wire. So therefore we can rearrange it and make m to be the subject and say m is equal to BIL over g, pop our values in, and then we work it through to be 3.1 times 10 to the minus 3 kilograms, which our answer is B. The next question says two charged particles P and Q move in circular orbits in a magnetic field of uniform flux density. The particles have the same charge, but the mass of P is less than the mass of Q. Time P is the time taken for particle P to complete one orbit, and TQ is the time for particle Q to complete one orbit. Which of the following is correct? So pause the video now, then unpause the video when you want to go through your answer. Right, our answer here was going to be C, because once again, if we've got a circular orbit due to the magnetic field, we can say the magnetic force is equal to the centripetal force. So therefore we can rearrange that and say R is equal to mv over bq. Rearrange it, make V the subject, and say V equals bqr over m. So if the radius is the same, the charge is the same, and the magnetic field strength is the same, a larger mass will therefore give a smaller velocity, so will take a longer time to complete an orbit. So the charge with the larger mass, Q, will have a longer time to orbit than the lighter one, P. The next question says, the diagram shows a vertical square coil whose plane is at right angles to a horizontal uniform magnetic field B. A current I is passed through the coil, which is free to rotate about a vertical axis OO'. Which of the following statements is correct? So pause the video now, then unpause the video when you want to go through your answer. Right, our answer here is A, because each side of the coil will experience the same magnetic field strength, has the same length, and has the same current as it's in one series circuit, which means each side will experience the same magnitude of force, because F equals BIL, and B, I, and L are the same values for each side of the square. However, the current in the opposite sides of the square are flowing in opposite directions, so therefore the force must be acting in different directions, in opposite directions on each side, giving our answer A. Let's have a look now at a few questions on thermal physics. So a gas cylinder has a volume of 0.02 meters cubed and contains 88 grams of carbon dioxide at a temperature of 27 degrees Celsius. What is the gas pressure? So pause the video now, then unpause the video when you want to go through your answer. Right, our answer here is D, because we need to use our ideal gas equation of PV equals nRT. We can rearrange it to make P the subject, so P equals nRT over V. Now the trick is T has to be in Kelvin, so we do 27 degrees Celsius plus 273 to get it into Kelvin. We can then also work out what our value of N, the number of moles, is going to be by dividing our mass by the MR of carbon dioxide, which is 44. So therefore 88 over 44 gives us our number of moles. So therefore we can work everything through, and therefore we get our answer to be 249544 pascals, which when you work it through is 249,000 pascals, which our answer is D. The next question says, a 1 kilo ohm resistor is thermally insulated and a potential difference of 6 volts is applied to it for 2 minutes. The thermal capacity of the resistor is 9 joules per coulomb. The rise in the temperature in Kelvin is what? So pause the video now, then unpause the video when you want to go through your answer. Right, our answer is going to be C, because you know that power is equal to V squared over R. We use this one because we've got R and V in the question. So therefore we can work it through, remember converting 1 kilo ohm to 1000, and we get our power to be 0.036 watts. Now we know energy is power times by time, so the energy that we've expelled in this particular time of 2 minutes, which is 120 seconds, is 4.32 joules. Now we know that a change in temperature is equal to the energy over the mass times by the specific heat capacity, because we're using the specific heat capacity equation of E equals mc delta T. So therefore delta T is going to be E over mc. So therefore we can pop all our numbers in. We know what our energy is, 4.32. We know our mass is 1 kilogram, and we know that our specific heat is going to be 9. So therefore what we can do is we can work it out to be 0.48 Kelvin. The next question says, a 60-gram solid metal sample is heated by an electrical heater. The heater operates at a voltage of 230 volts and with a current of 1 amp. The temperature of the sample changes as shown before. What is the specific latent heat of vaporization of the metal? So pause the video now, then unpause the video when you want to go through your answer. Right, our answer here is D, because the latent heat of vaporization is equal to the work done over the mass, because E equals ml, so therefore L is going to be equal to E over m. Now we know that work done is equal to power times by time, but we know that we've been given the current and the voltage, so we can say that power is VI, so therefore work done is V times by I times by T. Therefore all divided by the mass to give you the latent heat capacity, so you can pop it through and you work out to be 245 times 10 to the 3, which gives us an answer of approximately D. The next question says the temperature of a room increases from 283 Kelvin to 293 Kelvin. The RMS speed of the air molecules in the room increases by a factor of what? So pause the video now, then unpause the video when you want to go through your answer. Right, our answer here is going to be B, because you know that from the equations given to us, a half mc squared is equal to 3 over 2 kt. Now we're going to try and work out C, the RMS speed. So therefore, because mass and k are going to be constants in this instant, we can therefore say that 3c squared is equal to t when we've just taken out m and k and then moved around our numbers there. So therefore C is going to be equal to square root t over 3. So, I'll repeat that. C equals the square root of t over 3, just to make sure you're clear on that. So therefore what we can do is 10 over 3 all square rooted equals 1.04, which is their answer B. The next question says a fixed mass of ideal gas initially has a volume V and an absolute temperature T. Its initial pressure could be doubled by changing its volume and its temperature to what? So pause the video now, then unpause the video when you want to go through your answer. Well, our answer here is going to be B, because the ideal gas equation is PV equals nRT, so therefore P equals nRT over V. So to double P, you could either half T from the question, or you could quarter V, and then you would work it through like that, so our answer would therefore be B. The next question says a fixed mass of gas occupies a volume V. The temperature of the gas increases so that the root mean square velocity of the gas molecules is doubled. What will the new volume be if the pressure remains constant? So pause the video now, then unpause the video when you want to go through your answer. Right, our answer here is going to be D, because you know that V over T is a constant. That is just an ideal gas law, or just an empirical gas law as well. So this tells us that as the volume increases at the same proportion as the temperature increases. So because you know T is proportional to C squared, therefore it tells us that if C has been doubled in the question, the root mean square velocity has been doubled, therefore T is quadrupled. So if T is quadrupling, to get the same ratio, our constant, we need V to quadruple as well, because V over T is the constant. So therefore our answer is D. The next question says, which graph shows how the pressure varies with volume for a fixed mass of an ideal gas maintained at a constant temperature? So pause the video now, then unpause the video when you want to go through your answer. Right, our answer here is going to be B, because as the pressure increases, the volume decreases in inverse proportion, which is Boyle's law, PV equals constant. So the only graph here which shows inverse proportion is B. Let's now have a look at a few questions on nuclear physics. So the first one says, which of the following best describes the decay constant for a radioisotope? So pause the video now, then unpause the video when you want to go through your answer. Right, the answer here is D, because the decay constant is log 2 over half-life, which again is an equation given to us in our exam book. So this means that the constant proportionality linking the rate of decay and the number of nuclei is therefore going to be our decay constant, so therefore the answer is D. The next question says an alpha particle moves at 1/10 the velocity of a beta particle. They both move through the same uniform magnetic field at right angles to their motion. The magnitude of the ratio of the force on the alpha particle to the force on the beta particle is what? So pause the video now, then unpause the video when you want to go through your answer. Right, our answer is going to be B, B, because it's a particle moving through a magnetic field. The magnetic force is equal to BQV. That's an equation given to us in our equation book. Now, the magnetic field strength, B, is the same for each particle because it's a uniform magnetic field. So this gives the alpha particle double the charge, yet 1/10 the velocity compared to beta. Now, it tells that because in the question it's moving at a velocity of 1/10, and we know that the charge on an alpha particle is double because we know that an alpha particle has 2 protons and 2 neutrons, whilst the beta is just 1 electron, so it's got double the charge. So therefore, when we work it all through, it tells us we've got a ratio of 1/5. So our answer is B. The next question says, a radioactive nucleus emits a beta minus particle, then an alpha particle, then finally another beta minus particle. The final nuclide is what? So pause the video now, then unpause the video when you want to go through your answer. Well, our answer here is A, because the beta particle is coming from the beta decay process, which is turning a neutron into a proton. So this happens twice because it's happened in 2 instances. So the proton number in our nucleus has increased by 2, but the alpha emission releases a helium nucleus, so it reduces the proton number by 2. So when you've increased it by 2 with beta minus decay, but decreased it by 2 with alpha emission, this means that the proton number stays the same. So it's the original element. It's A. The next question says, the actinium series of radioactive decay starts with an isotope of uranium of mass number 235 and proton number 92. Which line in the table shows the nucleon number and proton number of the isotope after the emission of 5 alpha particles and 2 beta minus particles? So pause the video now, then unpause the video when you want to go through your answer. Right, our answer here is going to be C, because 5 alpha particle emissions will lose 10 protons and 20 nucleons in total, because an alpha particle is 2 protons, 2 neutrons, so that's 4 nucleons and 2 protons, whilst the beta particle emissions will gain 2 protons and you'll have gained 0 nucleons, because you're turning a neutron into a proton, so you're gaining a proton in beta minus decay, but you're also emitting a beta minus particle and you're emitting an antineutrino, which both aren't nucleons. So overall, with these processes, 8 protons have been lost and 20 nucleons have been lost. So when you work it all through, that gives us an answer of C. Right, the next question says here that the diagram shows a path of an alpha particle deflected by the nucleus of an atom. Point P on the path is the point of closest approach of the alpha particle to the nucleus. Which of the following statements about the alpha particle on this path is correct? So pause the video now, then unpause the video when you want to go through your answer. Well, the answer here is going to be D, because at the closest point between the alpha particle and the nucleus, all of the alpha particle's kinetic energy has turned into electrical potential energy due to the repulsion between the positive nucleus and the positive alpha particle. So therefore the alpha particle reduces its movement to a minimum. So the answer is D. The next question says, a beam of alpha particles irradiates a metal foil. The path of 4 alpha particles near the nucleus of a metal atom are shown in the diagram. Which of the following paths must be incorrect? So pause the video now, then unpause the video when you want to go through your answer. Well, the answer here is D, because the alpha particle and the nucleus have to repel each other because they've got the same electrical charge. They're both positive. So D shows an attraction which can't occur, so that is the incorrect path. The next question says, in the Rutherford alpha particle scattering experiment, alpha particles have the same energy fired at gold nuclei. The diagrams below are intended to represent encounters between 2 alpha particles and a gold nucleus N. The alpha particles arrive in at different times. Which one best represents the possible encounters? So pause the video now, then unpause the video when you want to go through your answer. Right, the answer is A, because the alpha particles are repelled from the nucleus, so any attraction can't be the case, and also the closer the alpha particle to the nucleus, the stronger the electromagnetic repulsion it will experience, so the greater its repulsion will be. So therefore, when you look at the particular answers, you can tell that the only ones which satisfy both of those particular criteria is A. So that one best represents the possible encounters. The next question says, the sodium isotope 2411 is a radioactive isotope that can be produced by bombarding the aluminium isotope 2713 with neutrons. Which line in the table correctly represents the production of 2411 sodium from the aluminium isotope 2713 and its subsequent decay? So pause the video now, then unpause the video when you want to go through your answer. Right, the answer here is going to be B, because the sodium isotope is produced with the release of an alpha particle. So therefore you can see it going on, because it wouldn't just produce a 3,2 helium, so it has to be produced with an alpha. And then secondly, since the sodium is going to be a neutron-rich nucleus, the decay you'll have after that'll occur will be beta minus decay. So you can see here the correct satisfaction of the beta minus decay is the line which is shown as B, so therefore that is our solution. The next question says, which of the following is equal to the radius of the nucleus of SB with the radius of the nucleus Zn? So pause the video now, then unpause the video when you want to go through your answer. Right, in this question our answer is going to be B, because as this is a ratio we can ignore our constant term of R0. Now we can work out the radius of the nucleus by doing the equation R0 a to the power of a third, but like I said before, because we're in a ratio, R0 cancels through because it's the same for both nuclei. So therefore we can work out the radius of SB by doing 125, which is our value of A, which is the nucleon number, to the power of a third, which is 5, and then we can do the radius of Zn by doing 64, the nucleon number, to the power of a third, which is 4. So therefore it's going to be 5 over 4, which gives us a ratio of 1.25. So I hope you've enjoyed this particular revision session. If you've been successful and you've learned in this revision session, you should be able to answer A-level physics examination style questions, assess your understanding on A-level physics, and finally understand what topics you need to improve upon for A-level physics. So thank you very much for watching this revision session on AQA A-level physics. Thank you very much and have a lovely day.